Hi, this is an introduction to the Vehicle Energy Use Simulator. Before we start taking a look at this program, let's run out to the private energy website that sponsors or features the Vehicle Energy Use Simulator and take a look at a couple of different points. One of the first things you see when you come out to the website, the private energy website, is that the main screen of the program is running 1300 pixels by 710 pixels. And we have it being shown here running on a MacBook Air with a 1300 wide screen, 1300 pixel wide screen. And we went ahead and tried running the program on 1280 pixel wide MacBooks, and it runs just fine. It runs absolutely flawlessly, but you will be missing on the 1280 pixel screens those 20 pixels out on the right side of the frame of the program. Now, no functionality whatsoever is lost and everything works absolutely beautifully, but you will be missing those 20 pixels on a 1280 screen. Another reason for bringing you to the website is we wanted to talk about each of these buttons that are along the bottom of the program. When you're running the program and clicking on the buttons like this, you'll have different windows that open up and assist and help run the program and help you load up different kinds of variables that the simulator needs. Those same buttons are all featured and replicated out here on the website. For instance, we're looking at the main program screen right now, but let's take a look at the vehicle setup, which is that first button. And this is a screen that'll pop up on the program itself. Looks identical to this. And here on the website we explain an awful lot of detail about how the program functions and the different kinds of things that are available to you by using these different screens if you ever have any trouble with any of them or need some further information than what the program seems to be giving. Now, we do provide out on the program information buttons on almost every field, and an awful lot of good info is there, but the website assists in backing up some of that kind of information and with some detail. Here's the vehicle graphics, the fuel motive. You can come out here and find out the different kinds of motive systems and fuels that you can apply in your simulations: methanol, ethanol, compressed natural gas, diesel, full electric, butane, propane, etc. And gives, like I say, more detail about those kinds of things. The environment, the road rolling resistance, tire rolling resistance screen, the exterior cargo screen. All of those buttons show you exactly the same kind of screen that is being used in the program. Let's go ahead and go back to the program now. When you begin using the program, the first time you open it up, you'll see a screen that looks very similar to this. This is a screen where a full electric vehicle is being set up, and you'll see that it shows 105.9 miles per gallon E. That means equivalent. That's an EPA rating that is given to non-fluid or non-liquid fuels so that we can compare them to liquid fuels that most of us are used to comparing mileage to or efficiency to of a vehicle. Because most of us aren't ready and this is not a good vehicle to learn on, we set the program up with a Get Vehicle button down here where you can actually open that button or click on that button and open up this window that has several different vehicles pre-designed that are common to those that run up and down the highways in the USA. And go ahead and pick one that you're used to. I personally drive a Camry Hybrid LE, so I'm going to click on that button, and you'll see that my data has all changed to a 2012 Toyota Camry Hybrid. Now, another thing we'd like to point out is the graphics for the vehicles that you're designing and playing with and simulating for are just representative of the type of vehicle. In other words, this is not really, if you look at it closely, a 2012 Hybrid LE, Camry Hybrid LE. And this is not really it's just a generic vehicle, a generic van. This is not really any sort of specialized van whatsoever. These are all just generic types of vehicles. Now, because I'm running a four-door sedan, I've picked this nice red car. I like red cars, so that's what I picked to represent my Toyota Camry Hybrid LE. Most of the work that you'll be doing on these kinds of program are out here on this compass, and if you'll notice when I start using the scroll feature of the mouse or the mouse pad, the vehicle is moving. If I double click and change this to wind and start scrolling, then the wind arrow moves. Now, that wind arrow is representing the direction from whence the wind is coming toward the vehicle. So it says down here wind is from 37 degrees, and sure enough it's pointing at 37 degrees on the compass, indicating that a 9-mile-an-hour wind is coming at the vehicle and spreading over the vehicle from that point on the compass. The vehicle itself shows that it's traveling toward on the compass at toward 334 degrees or north-northwest. The vehicle speed is 70 miles an hour. You can change the speed with this button. You'll notice that when you make these changes, an awful lot of other data points on the program change instantly. Now let's run it back up to 70 miles an hour, and then you can change the vehicle direction with this button, or again when you scroll with the mouse pad or the mouse scroll wheel. Most of that kind of information can be found by pressing on these info buttons. Here it talks about running the mouse wheel and double clicking on the white compass area, etc., etc. Another feature that it can be shown is that we need to show you is that when you're moving the wind, you'll notice that the opacity or the translucence of the wind is getting lighter and lighter as I came toward the back of the vehicle. There are a couple of reasons for that. The wind, as it travels toward the back of the vehicle or toward the front of the vehicle, does change its opacity or its translucence to indicate what kind of effect the wind is having upon the vehicle's efficiency. Right now we're getting 40.44 miles per gallon because the wind is causing a 7.39 mile per gallon loss. You'll see these numbers change now as I scroll that mouse more toward the front of the vehicle. Now we're losing 8 miles per gallon and the mileage has gone down. If I go toward the back of the vehicle and the arrow becomes more translucent, you'll see that the negative effect of the wind is much less. And as I continue moving further back, the arrow actually turns green, indicating that the wind is actually assisting the vehicle's efficiency, and now we're getting a 4.05 mile per gallon gain because of the wind. Now the wind is at 9 miles an hour. If we increase that wind speed, we'll see that the gain goes up and that the arrow actually gets a little more opaque or a little darker. If I move it right directly behind the vehicle, you'll see that it actually darkens up quite a bit, and we're getting a 12.7 mile per gallon gain from a 14 mile an hour wind, and it's giving us 60.53 miles per gallon. That is an awful high mileage, but that's actually true. If we had a 13 or a 14 mile an hour wind directly behind the vehicle, in my Camry, that's exactly the kind of mileage I get if I don't have the air conditioning turned on. Let's turn on the air conditioning very quickly and watch the mileage drop. I just dropped to 55.28 miles per gallon with that 14 mile an hour wind. An interesting thing about the wind is that the national average daily wind speed in the USA is 9.2 miles per hour. So let's move this back down to 9 miles an hour to be closer to average. Now we see that the vehicle is getting 51.16 miles per gallon with a 9 mile an hour wind. It's about 8 or 9 miles an hour is where you begin seeing, really about 9 or 10 miles per hour is where you begin seeing the effects of the wind in the roadside grass and tree limbs and leaves on the trees when you're traveling down the highway at 70 miles an hour. But if you're going, say, 7 or 8 miles per hour, let's set it at 8, it's very hard at that point to discern the movement of the grass or the leaves and to know that you're traveling in any sort of wind at all. In fact, most of us, if we don't see the grass blowing or the leaves on the trees blowing as we're traveling down the highway, we don't think the wind is blowing very much. Well, this is about the speed where the evidence of the wind blowing it becomes less apparent to us as we have our windows rolled up, our air conditioning turned on, etc. And yet my Camry hybrid can get 50.37 miles per gallon in this kind of a environment. But if I move that same wind up here to say north-northeast, and I'll tell you how I did that in just a second, moving that wind very quickly, you'll notice that I dropped to 38.21 miles per gallon. So I've gone from a big, large gain to an actual loss, and yet I can't tell there isn't any wind. So that's what happens very, very often to people that think, oh my gosh, I got hold of some bad gas, or I've got to check out my car, something's wrong with it. I was getting 50 miles per gallon yesterday, today I'm only getting 38 miles per gallon. It's probably the wind that has been affecting you. In fact, there's a rule that we made up a rule called the 65-35 rule, and that is telling us that anytime there is wind at all out on the highway with your car, 65% of the time as it's approaching the vehicle from any of these areas in front of the car, 65% of the time it'll have a negative effect upon your mileage. Only 35% of the time will it have a positive effect upon your mileage. So that's the 65-35 wind rule. What I wanted to show you about to the compass here, any one of these 16 cardinal points, you'll notice when I'm running the mouse over them, 16 cardinal points of the compass, the mouse cursor turns into crosshairs, and if you click on those, then whatever this is set at will move that. For instance, it's set on wind, it moved the wind instantly to there. Let's move it to the west, move wind to the west. Now if I double click and change this to vehicle, now if I click on here, the vehicle moves. Or I go to northeast, the vehicle moves. Double click again, change back to wind, and now the wind will move instead of the vehicle. Now, a lot of times when we're running this simulator, we don't know whether or not the air conditioning was turned on or what the temperature we have set at. And as you get used to the program, you'll say, why am I only getting 39.48 miles per gallon? Well, there's a button over here you can press, and it's called the data button. And it'll turn on a lot of data points that make it easy to check very quickly. Is the AC on? Yes. What's the climate control at? 75. What's the temperature? 92 outside. Humidity? 50%. Barometer? Elevation? All of those same values and variables can be changed on this screen. But if you've got that screen closed and you're working with the program, and you can see that all of these data points change instantly just as they do out here on the main screen, you can always keep track of what's going on and check your data quickly. For instance, sometimes I wanted to see what would happen if I changed my frontal area or my coefficient of drag, and if I do that, if I go ahead and open that and change my coefficient of drag, let's go ahead and do that. Right now I've got a 0.27 coefficient of drag. Let's change it to 0.25.